Okay, so we just now derived the equation of motion for a single degree of freedom system, and that equation looked something like this: mx double dot plus kx equal to 0. Okay, so I can write down this equation in this fashion, that x double dot is equal to minus k by m into x. Okay, which tells us that acceleration of the mass will always be proportional to x. Proportionality constant is k by m and is opposite of that of x. So this negative sign which is over here, okay, that negative sign tells us that if x is positive, x double dot will come out to be negative. If x is negative, x double dot will come out to be positive. Okay, so x positive, x double dot will be negative. Similarly, when x itself is negative, x double dot will be positive. Okay, so sign of x and x double dot will always be opposite to each other. Okay, so let's say if this is where the mean position of the mass is, so if mass is displaced in such a way that this is what is x, okay, then acceleration will always be in this direction. Okay, so when mass is displaced towards the positive side, acceleration will always be in this direction, which essentially means that spring force which will be acting onto it will always be in this direction. So spring force will always try to push it towards the mean position. Okay, so whenever you are over here, spring force is trying to push it over here in the mean position. Okay, so in a similar sense, when displacement is negative, this is displacement. Okay, okay, here the displacement was positive, here the displacement is negative. Okay, so when the displacement is negative, because of this particular relationship between the displacement and acceleration will come out to be this one. Okay, so this is what is the acceleration. Okay, this is force, spring force. Spring force is always acting in this direction. Okay, so whenever the mass is displaced towards the negative side of the mean position, spring force will always try to push it again in this direction towards the mean position. When you are at the mean position, there is no x, so there is no any spring force. Okay, so spring force is also 0, x is 0. X is 0, x double dot is 0, and spring force is also 0. Okay, so when you are over here in the mean position. Okay, so in any of the case, okay, what mass is trying to do is, mass is trying to come back to the mean position. In no case mass is allowed to fly away from the mean position. Okay, so that's why the mass is oscillating. Okay, it is trying to go away, but it is not allowed, so it has to come back. Okay, when it comes back, then it again is trying to go to the other side, which will try to see that why it happens, why it is going towards the other side. Okay, so what is happening over here at the mean position, which is pushing it over here. Okay, on the other side, we'll try to see to it very soon. Okay, but when it goes to the other side, again in that case also, it is not allowed to fly away from the mean position towards this negative side, but again there will be one more force acting onto it, which is the spring force itself. So that force will try to push it inside. Okay, so either you go towards here or you go towards here. The nature of the force which is acting on the mass is pushing it inwards towards the mean position. Okay, so that is what is causing the mass to oscillate, and this force is what is given by spring force, which we call as internal resistive force. Okay, so this is internal resistive force which is resisting the motion. Okay, which is resisting the displacement of that particular mass. Okay, so I hope the equation of motion and its meaning is clear to you. So this is the equation of motion. Okay, mx double dot plus kx is equal to 0. Okay, this is the equation which is governing the motion of the mass particle. Okay, okay, where m is mass block and k is the stiffness of the spring. And as I already have told you, so these are the two quantities which are going to determine the behavior of the mass. Okay, so how mass is going to oscillate, that depends on what is the value of m and what is the value of k. We'll try to see to the nature of the solution and how that depends on mass and k values very soon when we'll find out the solution of it. Okay, so let's stop over here for today.